Well, this is section 1.2. Gauss-Jordan elimination method. In general, the Gauss-Jordan method is a method to solve a system of linear equations. By working on the augmented matrix. All right. In the next, I'm going to see a couple of examples to explain the method in detail, but we are going to assume the next examples will show the method when the system has solution. Yeah, the next examples I'm going to cover, they are when we have only one solution for the systems or the systems of linear equations. So maybe you wonder, so what's happening when we don't have solutions, or how can we know the several solutions? Well, that's going to be covered in the next section. But by now, I want to focus on this video that on what how is the method for Gauss-Jordan. Other cases, will be covered later. All right, example. Let's say that we have the system x minus 2y plus 3c equal to 7, 2x plus y plus c equal to 4, negative 3x plus 2y minus 2 times c equal to negative 10. So here we have three equations, equation 1, equation 2, and equation 3. So there are some methods that we can use to solve the system by working only on the equations directly. But again, here Gauss-Jordan method consists of working on the augmented matrix. So first, obtain the augmented matrix. So remember, the augmented matrix is the matrix of the coefficients for each equation. We have to put the coefficients here, and of course one equation corresponds to one row. So if we have three equations, we're going to have here three rows. Now for example, for the first equation, we have the coefficients are 1, -2, 3, and 7. And here to the this is okay, but if we want to point out that this corresponds to the right side of the equation, then we can put a vertical line like this. And then for the second equation, 2, 1, 1, and 4. For the third equation, -3, 2, -2, and -10. And there you have. Remember that when you see only the variable, like in this case the x alone or the y alone, then, or the c alone, in that case you have to assume that the coefficient is 1. So be careful with that. All right, this method is about that we need to transform or turn this matrix into something like this. One, zero, 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 1, 0, 0, 0, 1, and here we're going to we will have here some numbers that I'm going to call solution 1, solution 2, and solution 3. Yeah. So the key of this method in general for the Gauss-Jordan method is that we start with the augmented matrix, and we must be able to turn this matrix into this form. But you say, well, but how? How can we do that? Of course, yeah, this is like a game where we have certain rules. The rules are going to be the row operations allowed. What are those? I'm going to specify them. But yeah, in general, the method is try to turn this into this. It's not going to be always possible to turn this into this exactly. But again, the examples I'm seeing in this video is then when it is possible. How to deal when it is possible, because there is only one solution for the system. But what happens when we have a different cases? Those cases are going to be covered in other videos, in the next video actually. All right, by now, so we have row operations allowed. These are the elementary row operations. All right. How are we going to accomplish our purpose? So, number one, we can interchange any two rows. So if, for example, here, if for some reason you want to put the row number 1 at the row 3 and the row 3 at the row number 1, no problem. We can do that. We are allowed to do that. Interchange the order of two rows. Number 2, multiply, but essentially a division is a multiplication, so we can put here or divide any row by a scalar different from 0. Scalar in this video is going to be only a real number. Number 3, this I think is the most important. Add or subtract 2 rows and use the result to replace any of the 2 rows. So, as for operation number 2 and 3, operation number 2, multiply or divide any row by a scalar different from 0. So you want to multiply any row or divide any row by any scalar that is not 0, no problem. We can do it. For example, you want to multiply the row 1 by 2, no problem at all. You want to divide the row 3 by 3, no problem. Now, the operation number 3, I think is the most important again. But why? Because it's, I think, the key to accomplish or to do the Gauss-Jordan method. It says add or subtract 2 rows and use the result to replace any of the 2 rows you just used. All right. For example, if at some point you want to add the row 1 with the row 3, and what do I mean with adding? I mean that you can add element by element. This one with this one, this one with this one, this one with this one, and this one with this one. Yeah? You can add the 2 rows, and then after that, you will have 1 row. That result, that row, you can use it to replace either the rows you just used, row 1 or row 3. Yeah? So add or, well, and it's the same for subtraction. Add or subtract 2 rows and use the result to replace any of the 2 rows you just used. All right. So first, well, I mean, let's do the example. But first, I'm going to use some numbers called the pivot. This is not a formal definition for a pivot, but by now it's going to be useful. Set the pivot. What is the pivot? I will explain. The pivot is a reference number. All the entries, this is like a guide. All the entries in the column of the pivot must be 0. Except the pivot itself. And the pivot is also used to clear numbers. I mean, turn them into 0. So, all right, so again, I'm going to work on this example. This one. I will turn this matrix into this one by using these operations. So, right, this is like again like a game. These are the rules we are allowed to do. And by this, the pivot is going to be a number of reference. What for? Well, first, all the entries in the column of the pivot must be 0, except the pivot itself. And the pivot is going to be also used to clear numbers. By clear numbers, I mean turn them into 0. All right, we're going to be seeing this as I am explaining this. But first, totally do it. I have here this matrix. Let me copy this again. 1, negative 2, 3, 7. Two, 1, 1, 4. Negative 3, 2, negative 2, 10. All right. So the pivot is going to be first, we're going to have 3 pivots. The first one is going to be the first non-zero entry in the row 1. First non-zero entry in row 1. So that is going to be my first pivot. What is this for? Again, this is like a reference. All the numbers in the column of the pivot must be 0, except the pivot itself. And I'm going to use the pivot to do that. For example, these 2 must be 0. I need to turn this into 0. But how? By using these operations, any of these operations. So how can I do it here? My recommendation is that you use the pivot and the number you want to change. For example, I have 1 and I have 2. The key is that you have the same number here and the same number here. Or well, maybe not exactly the same, maybe the same, only except for the sign. I mean, one positive, one negative. But definitely, we need to have the same number here, maybe positive, maybe one positive, one negative, but the same number. So how to do that? For example, I have the pivot 1 and this 2. What about if I multiply this 1 times 2? I can do that, yeah, but of course, I mean, I cannot multiply only this number, but I can do it for all the row. And the first operation is going to be that one actually. 2 times row 1. With this I have 2 here. And after that I will have 2 and 2. Now, once you have the same numbers, we want to turn that into 0. So if we have 2 and 2, subtract. 2 row 1 minus this number is located in the row 2. So minus row 2. And after that, we're going to have one result. This is going to replace the row 2. And now pay attention to something here. The structure of the operations is recommendable. They have this one. Row of the pivot, row to change, this arrow means will replace row to change. Row of the pivot may be multiplied by a constant, plus or minus row to change will replace row to change. It's recommendable that the operations indicating sum of subtraction of row, they have this structure. You're going to be seeing this as I am completing this exercise. So after that, I will have 0 here. Now, what about this one? Now we need to turn, after that, we need to turn this into this. So again, use the pivot and the number you want to change. I have 1 and I have -3. What about if I multiply this times 3? I will have here 3 and -3. How do I cancel that? By adding. So the next operation is going to be 3 times row 1 plus row 3, row the pivot plus row to change. We replace the row 3. And after that, I'm going to have a new matrix. Notice, in this step, I'm going to change only row 2 and row 3. But the row 1 must be as it is always in the last matrix, since I haven't modified this matrix yet. So my last matrix is the first one. So this is going to be my reference. So row 1 as it is, 1, -2, 3, 7. But now I have an operation that I have to do. 2 row 1 minus row 2. All right, so multiply the row 1 times 2 and then subtract row 2. 2 times 1 is 2, minus 2, 0. Be careful with the signs. 2 times -2 is -4, minus 1, -5. 2 times 3 is 6, minus 1, 5. 2 times 7, 14, minus 4, 10. You see? But now I have a 0 here. See that? 0. Now this operation. 3 row 1 plus row 3 replaces row 3. 3 times 1, 3, plus -3, 0. 3 times -2, -6 plus 2, -4. 3 times 3, 9, plus -2, 7. 3 times 7, 21, plus, I think, oh yeah, this is -10. I'm sorry. Be careful with that, because a little mistake when you put the numbers and everything is going to be wrong. So I think it's correct. So I'm sorry, I was doing the last number. I'm doing this operation. 3 times row 1 plus row 3. 3 times row 1, 21. 3 times 7 is 21, minus 10 is 11. And there you have. But notice, what do we have here? We have 0 and 0. After that, we're done with that pivot. Now we have to set a new pivot. That's going to be the first non-zero entry in the row 2. I mean, the number in this position. But first, one hint. It's highly recommendable that if you divide any row by, when you see that all the numbers are multiple for one number. For example, here in the row 2, I observe that I have -5, 5, and 10. So I can divide all of this by 5. And maybe with that, I can save some computation. So here it's going to be row 2 divided by -5. And this will replace the row 2. After that, my new row is going to be what? Row 1 and row 3 as they are. 1, -2, 3, and 7. 0, -4, 7, and 11. But now I have a new row 2. Divide every element of the row 2 by -5. 0 by -5 divided by -5 is 0. -5 divided by -5 is 1. 5 divided by -5 is -1. And 10 divided by -5 is -2. See that? And now I have something simpler, right? I think this is 1. Now, this, again, set a new pivot, is going to be this entry. Pivot. What is the purpose of the pivot? The same as before. All the elements in the column of the pivot, all the elements must be 0 except the pivot itself. And use the pivot to accomplish that. For example, I have 1 here and I want to turn this -2 into 0. Use 1 and -2. How to do that? Again, these two numbers, the pivot and the number you want to change must be the same, or maybe the same except for the sign. If I have -2 and 1, what about if I multiply this 1 times 2? After that, I will have 2 and -2. How do I cancel that? How do I clear that? Addition. So the next operation is going to be 2 row the pivot. Notice how the row the pivot now is 2, row 2. So 2 times row 2 plus row 1. Why row 1? Because this -2 is in the row 1. We'll replace the row 1. See that? Next, this pivot, I have 1 and -4. Use the pivot and the number you want to change. I can multiply this times 4. 4 times row 2. After that, 4 times 1 is 4. 4 and -4, how do I cancel that? Addition. Plus row 3 will replace row 3. Again, note the structure of the operations in this case. Row the pivot may be multiplied times a constant, plus or minus row to change will replace row to change. Row the pivot plus or minus row to change will replace row to change. Row the pivot, row to change will replace row to change. After that, the row 2 is going to be the same. Again, I'm going to change here only row 1 and row 3. Row 2 as it is based on the last matrix. This is my last matrix, so row 2 is going to be 0, 1, -1, and -2. Now, new row 1. Let's do the operations. 2 times row 2 plus row 1. 2 times 0, 0, plus 1, 1. 2 times 1, 2, plus -2, 0. 2 times -1, -2 plus 3, 1. 2 times -2, -4 plus 7, 3. Now this one, 4 row 2 plus row 3. 4 times 0, 0 plus 0, 0. 4 times 1, 4 plus -4, 0. 4 times -1, -4 plus 7, 3. 4 times negative 2, negative 8 plus 11, 3. And notice how now we have here 0 and 0. So we're done with this pivot. What is going to be next? If you guess, yeah, it's going to be set this number as the new pivot, the number of this position. So the pivot is one pivot, clear the column, except the pivot, other pivot, clear the column, except the pivot, and set a new pivot, clear the column, and if there were even 4 rows, set the pivot, clear the column, and so on. See that? And so on. But notice here I have 3 and 3. So what about if I divide this by 3? We put it here. Row 3 divided by 3. We replace the row 3. And the matrix is going to be the same except for the row 3. 1, 0, 1, 3. 0, 1, negative 1, negative 2. And divide the row 3, every element of the row 3 by 3. It's going to be 0, 0, 1, 1. And yes, now I have to set a new pivot. The first non-zero entry in the row 3. New pivot. What do I have to do with this? All the elements in the column of the pivot must be 0, except the pivot itself. So, what are going to be the new operations? Again, remember, this number must be 0, this number must be 0. Use the pivot and the numbers you want to change. What about this one? 1, how do I change this 1? I have 1 and 1, so I can subtract. Row 3, row the pivot, minus row to change, row 1 will replace row to change, row 1. After that, we have 0 here. What about this one? Again, use the pivot. 1, negative 1. Add row 3 plus row 2 will replace the row 2. And after that, my matrix is going to be what? The row 3 as it is. It's not going to change in this step. So row 3 is 0, 0, 1, and 1. Now row 1, new row 1. Subtract row 3 minus row 1. 0 minus 1, negative 1. 0 minus 0, 0. 1 minus 1, 0. And 1 minus 3, negative 2. Now this operation, row 3 plus row 2 will replace row 2. Row 3 plus row 2, 0 plus 0, 0. Zero plus 1, 1. 1 plus negative 1, 1 minus 1 is 0. And 1 minus 2, or 1 plus negative 2 is negative 1. And what do we have here? Now we have 0, 0. See that? After this, what is next? All the numbers you have here in this diagonal must be 1. That is very simple. Don't worry so much if you don't get the numbers. If you don't get the numbers as 1 before this step. I mean, it's very easy. Once you have completed the zeros, 0, 0, 0, 0, 0, only divide each row by the number you see here to turn this into 1. Fortunately, this is 1 and this is 1 already, but this one is not 1. So I need to divide or multiply this row by negative 1. And that's going to be my next operation. Row 1 divided by negative 1 we replace row 1. And then I'm going to have 1, 0, 0, -1 by -1 is 1, 0, 0 by -1 is 0, -2 by -1 is 2. And this one and the other rows are there. 1, 0, -1, 0, 0, 1, and 1. After this, we are basically done. Remember that each column corresponds to the coefficients of one variable. So this is for y, for x, this for y, and this for z. So once you have this, now go back to the system of equations. For example, for the equation number 1, we have 1x plus 0y plus 0z equal to 2. So the first equation is x equal to 2. This implies x equal to 2. With the same reasoning, y is equal to -1 and z is equal to 1. 0x plus 1y plus 0z equal to -1. Y equal to -1. 0x plus 0y plus 1z equal to 1. Z equal to 1. And there you have, this is the solution. So, well, this was the Gauss-Jordan method. I know that maybe you know other methods, and I know that even with that you can use some software or web page to compute the solutions. I don't have any problem with that. This is an online course, but I highly recommend that you try to practice this method. Try to solve as many as possible the exercises from Webwork with this method that we have here. Anyway, if you go to Blackboard, I have posted on Blackboard one recommendation for a page to compute, to verify the answers. There are many, of course. Maybe you already know many of them, but here in this folder, tools for the course, finding the solution for a systems of linear equations. So you click there, you will find this web page is I think it's amazing because it gives you the answers and it can give you even the solutions. So in this case, we need to have in our problem we have we started with this. You need to put the coefficient for the metric. We have 3 equations. So I need to put only 3. I need to put the coefficients. The coefficients, they are 1, -2, 3, and 7. 2, 1, 1, 4. And -3, 2, -2, and -10. And then you can choose the method. You see that there are many methods. So let's use the Gauss-Jordan. And there you have. You see, you're supposed to have even the steps. Maybe they're going to be slightly different as the ones that I have indicated. No problem. The process essentially should be the same. And the solutions here you have. There are 2, -1, and 1. And it's the same we have here, right? 2, -1, and 1. Yeah. Here, these ones. You see? So if you want to use this web page to verify the answers or to compute the answers, again, I don't have any problem with for the assignments on web work. But again, I highly recommend try to practice this method, right? Because this process is, especially the row operations, we're going to be using that later in this course. All right, that's all by now. If you have any question, remember you can send me an email and I will help you. If you need assistance with this method, you can attend my office hours. Check Blackboard for that, or we can set an appointment for a virtual meeting. No problem, right? Feel confident to ask any question. I know that this interaction is not very simple, right, online. But if you have any question, no problem. Let me know. All right. See you in the next video.